Alright, it's time for the solutions for the factoring quadratics. So on this first video, I already tried to make it, and I got all the way to 12, and I tried to save the video, and it decided not to save it. So I'm already going to have the solutions up for you, but I'll try to explain what's going on and go from there. So these ones are more complicated than the previous quadratics we've dealt with. Mostly because they have a different number up front, and that changes the formation of the two binomials. To guide you along with this, what you can do is you take your leading coefficient and you take the end one and you multiply them together. That'll give you this 120 here. And then you need to figure out what factors of 120 add to give you negative 29. Well, in this case, it gives you 5 and 24, well, the negative version of both of those. And that's where I got these first two binomials here. Notice how there's no 3 in front of either of those ends. Because what you need to do to account for the fact that we multiplied by 3 is you need to then take both these numbers and attempt to divide by the 3. So that's where this divide by 3 comes from. Here on the negative 24, that is divisible by 3, and that becomes negative 8. Whereas this one, 5 is not divisible by 3, so you take the 3 and you put it in front of the n. And that's where this 3n minus 5 comes from. And this gives you the answer. And if you want, you can try double distributing or foiling through this, but you will get the answer of what you started with. And so this is the factored form of number 1. Moving on to number 2, when you multiply 3 and the negative 40 together, you'll get negative 120. And then the factors of that add up to be a negative 2 are negative 12 and positive 10. And so that's where my plus 10 and subtract 12 came from there. When you account for timesing by 3 by dividing by 3 on both of these, it works on the second one, which gives us subtract 4. It doesn't on the first one, which will give you the 3 out front. And that gives you your answer there. On number 3, again, we have a 3 and a negative 90 being times together to give you negative 270. We're trying to figure out the factors of that. The add would be 17. Conveniently enough, the 10 is again involved. Negative 10 and positive 27 will add to give you 17 in the middle. So that's where the plus 27 and negative 10 come from. We need to account for the timesing by 3 by dividing by 3. So divide by 3 on these. That'll give you 9 there. This one doesn't go evenly, so the 3 goes out front. 3b minus 10, b plus 9. Moving on to number 4. Again, timesing by the 3 and the leading coefficient and what's on the end there to get negative 30. When you have to figure out factors of that give you negative 7 when you add them. Well, that's just negative 10 and 3. And so we got positive 3 here, negative 10 here, divide them both by 3. And, oh, right here I messed up. That's not there. Anyway, 3 divided by 3 gives you a 1 here. So I have a 1 there. And then the other one, 3 doesn't go evenly. And so the 3 is going to be pulled out front. 3m minus 10, and the other one's n plus 1. Moving on to the next one. So 5 is more complicated because it's got bigger numbers. Well, what you can do to address that issue is divide them all by some sort of common factor. In this case, 3, because 3 goes evenly into all of those. And that'll give you a prime number here, which means we can't divide everything by the same thing unless these were also divisible by 7, but they're not. Anyway, so I divide all by 3. Then I'm going to pretend this is my new problem. I'm just going to set the 3 aside for a little bit until the end, and I'm going to deal with this 7k squared minus 54k minus 16. Well, you're going to take the 7 and the negative 16 and multiply them together. It gives you negative 112. And when you figure out factors of that give you negative 54 when you add them together. That is negative 56 and 2. And so that's where this subtract 56 and plus 2 come from. We're going to address the not having a 7 up front by dividing them both, attempting to divide them both by 7. It works in this one, which is going to give you the negative 8. But it doesn't work on this one, so you pull the 7 out front. You'll get 7k plus 2 in there. And k minus 8 for my first binomial. Hopefully you didn't forget about the 3 we pulled out. We just set it aside for a moment, and that also needs to go in front of our factors there. Moving on to 6, again, multiply the 3 and the 70 together. That will give you 210. When you figure out what factors that, add up to be 31. Well, that's pretty quick. 21 and 10 add to be 31. So that's where positive 10, positive 21 come from. Attempt to divide them both by 3. It works in this one, which will give you this plus 7. It doesn't work in the other one, so the 3 is going to come out front, which gives you 3p plus 10. And then one's p plus 7 for your 2 polynomials. And then number 7, I'm going to take the leading coefficient and the end coefficient there and multiply them. That'll give you negative 63. And when you figure out what factors that give you a sum of 62, well, that's just positive 63 and negative 1. And that's where the positive 63 and the positive 1 come from when you attempt to divide them both by 7 to address the 7 issue out front. It goes evenly in the first one, which will give you 9. It doesn't in the second one, but you move the 7 out front, and there you go. Moving on to 8, when you times the 5 and the 16 together, that'll give you 80. What factors of 80 add up to be 18? Well, that's just 8 and 10. So that's where the plus 8 here comes from and the plus 10 here come from. We need to address the 5 issue out front by attempting to divide them both by 5, and that'll give you 2 here. So that's where x plus 2 comes from. And this one doesn't go evenly, so the 5 goes out front. You get 5x plus 8 times x plus 2. Moving on to 9, this one's actually a lot easier than all the other ones because all you have to do is factor out x, and that's all you can do. So we have a binomial here, 3x minus 10, and then the x here, and there's no more like factors you can split apart there. On 10, we'll have the 2 and the negative 70 being multiplied together. This one can't be divided by 2, or else we divide everything by 2. But anyway, you get negative 140. The factors of that add to be negative 13 are negative 20 and 7. Yeah, so when you have those, you'll have subtract 20 at 7 there. Need to attempt to divide them both by 2 to take care of the 2 out front. It doesn't work on the second one, so the 2 comes out front. It does work on the first one, so you have subtract 10 there. 11, just like number 9, except you can factor out a 2 as well, so instead of just x, you have a 2x, because 2 goes in both those evenly. And when you divide them both by 2x, you'll get 2x and subtract 3. And moving on to 12, the 3 and 10 are going to multiply together to get you 30, and you figure out what factors combine to give you negative 31. Since it's negative, these are both going to have to be negative because that one's positive. So negative 30 and negative 1 are those factors. You'll need to attempt to divide them both by 3. And it works in the first one, giving you p minus 10, but it doesn't work in the other one, so it'll give you 3p minus 1. And since we have a little bit more time than the last time I made this video, we'll move on to number 13. 3 doesn't go into all those evenly, so we're going to take 3 and times by the negative 9, which will give me negative 27. And we need to figure out what factors add up to be 26. Well, that'd just be positive 27 and negative 1, because when you add those you get 26. And so we'll have our 2 binomials here, x plus 27, and then x minus 1. And when you adjust for the 3 out front by attempting to divide them both by 3, it works in the first one, which will give you x plus 9. But it doesn't work in the second one, so you can take this 3 and move it out front. We'll get 3x minus 1. And we get this guy. If you want, you can try and distribute them through and then combine like terms and know that it's going to give you this guy up here. Number 14, so this one's got some bigger numbers in it. What you can do to try to address that issue is get rid of a common factor. Well, 5 goes into all those evenly, so we'll take the 5, put it out front. 35 divided by 5 gives you 7. And then the 75 divided by 5 is going to give you 15. And then the 10 divided by 5 gives you 2 on the end. And now we factor out the 5. This is a lot smaller. And we're going to pretend like this is our new problem for a little bit. We'll take the 7, we'll times by 2, we'll get 14. And when you figure out what factors of 14 add up to be 15, well, that's just 14 and 1, both positive. So we'll have p plus 14, and then we'll have p plus 1. And we need to try to address this issue of the 7 out front, so we'll attempt to divide both by 7. It doesn't work in the second one, so we'll pull the 7 out front. Oops, 7p plus 1 plus 1. But it does work on the first one, so I'll have p plus 2 there. So that will give you the inside part, and now we need to still multiply by the 5 as well, so the 5 is still going to be out front, just to keep the scale up to where it's supposed to be. And yeah, we could do another one. So this one, they're not all divisible by 3, so we'll take the 3 and the 40 multiply together, give you 120. And when you figure out what factors of that add up to be 29, well, that's 24 and 5. And that'll give you, we're on k's now, so k plus 24 in my first one, and then we'll have k plus 5 in my second one. And we need to address the 3 issues, so we'll try to divide them both by 3. It works in the first one, giving you k plus 8. It doesn't work in the second one, so we'll pull the 3 out front. We'll give you 3k plus 5, and that'll give you that one.